Mazda builds cars around a philosophy most drivers have never heard of. It is baked into every component, every calibration, every suspension setting on every model, and almost nobody who buys a Mazda is ever told how to use it. Today, I am going through 15 Mazda-specific secrets that 99% of owners drive past every day without knowing exist. Some are features, some are settings, and one changes how the car handles every single corner. Let's get into it. Number 15. The break-in period. Mazda still recommends that nobody follows. Most modern car manufacturers quietly dropped the concept of a break-in period decades ago. Mazda did not. Open any current Mazda owner's manual, and the break-in section is still there, clear and specific. For the first 600 miles, avoid sustained driving at any single speed. Vary engine load regularly. Do not exceed 4,000 RPM. Avoid trailer towing or carrying maximum payload loads. Do not allow the engine to labor in a high gear at low speed. The reasoning is grounded in manufacturing reality. SkyActiv engines have extremely high compression ratios compared to most production engines, with SkyActiv G gasoline units running at 13 to 14 to 1, among the highest in the industry. The piston rings, cylinder walls, and bearing surfaces in any new engine need a period of microscopic wearing in to achieve their designed operating clearances. That process is disrupted by sustained single-speed running, which causes uneven wear patterns, and by high-load operation before surfaces have bedded correctly. Most new Mazda owners collect their car from the dealership, drive it home at a sustained motorway speed for 40 minutes, and never vary their pace deliberately again. The break-in happens, but inefficiently, producing slightly higher long-term wear than the optimized protocol would. 600 miles of varied speed and moderate load costs nothing and takes no additional time. It simply requires attention to what you are doing for the first few weeks of ownership. The next secret involves a system that has been silently working on your car every single corner since the day it was built, and most owners have never heard it mentioned. Number 14. G-Vectoring Control Plus, the system that controls every corner. G-Vectoring Control was introduced by Mazda in 2016. G-Vectoring Control Plus arrived in 2019. Between the two of them, they represent one of the most sophisticated chassis dynamic systems in any mainstream production vehicle, and almost nobody who owns a Mazda with either system knows it is operating. Here is what it does. As a driver begins to turn the steering wheel at the entry of a corner, GVC momentarily reduces engine torque. That reduction shifts a small amount of weight forward onto the front tires, increasing their grip at exactly the moment maximum steering effectiveness is needed. As the driver begins to unwind the wheel at corner exit, GVC restores engine torque, shifting weight rearward and stabilizing the car as it straightens. The GVC Plus version adds rear brake application during cornering. When the car detects understeer developing, the system applies a small amount of braking on the inside rear wheel, which gently yaws the nose back toward the intended direction without the driver feeling any intervention at the steering wheel. The result of all of this is a car that corners with less steering input required, tracks more accurately through bends, and feels more planted on corner exit than its weight and power figures would suggest possible. Every Mazda equipped with this system from 2016 onward has it running in the background of every single corner. It cannot be switched off. It requires no driver input, and knowing it is there explains why Mazdas feel dramatically more responsive than their specifications imply. Subscribe right now if you own a Mazda and nobody has ever told you this existed. Number 13. The Jinba Ittai seating position. Mazda engineers. For Jinba Ittai is a Japanese concept describing the unity between horse and rider. Mazda adopted it as the core of their human-machine interface philosophy, which means every Mazda is engineered around a specific driver position that optimizes the relationship between the human and the machine. That position is specific. Hip point approximately level with the knee, upper arm roughly vertical, forearms extending at a slight downward angle to the steering wheel with a slight bend at the elbow, when hands are at the 9 and 3 positions. Seat height adjusted so the top of the steering wheel is at approximately chin level. Most drivers sit lower than this, with the seat fully back and the steering wheel extended, creating a reclined posture that disconnects them from the car's feedback. In this position, steering inputs take more physical effort, chassis feedback through the seat is reduced, and the driver processes information from the car less efficiently. The Mazda intended driving position is more upright than most drivers are accustomed to and feels unusual at first. Adjusted to the correct position, the steering becomes more communicative, body roll is felt as useful information rather than disturbance, and the driver's inputs are naturally more precise because the arms are in a mechanically efficient position. After about 1 week of driving in the correct position, returning to the reclined position feels immediately less connected. The next secret is a physical feature inside the car that most owners have sat next to for years without ever activating. Number 12. Auto hold, the feature. Hiding on the center console. Auto hold is available on the majority of current Mazda models with automatic transmissions. It allows the car to hold full brake pressure at a complete stop without the driver maintaining pressure on the brake pedal. Engage it by pressing the brake pedal to a complete stop, then pressing the specific auto hold button on the center console. The brake indicator on the instrument cluster changes to show auto hold is active. Release your foot entirely from the brake pedal. The car does not move. When you press the accelerator to pull away, the system releases brake pressure automatically and the car moves normally. The practical benefit appears most obviously in stop-and-go traffic and at traffic lights. Rather than maintaining brake pedal pressure for 30 seconds at every red light, the driver can allow the car to hold itself and remove foot pressure entirely. Over a commute with multiple stops, the cumulative fatigue reduction is significant. Auto hold also functions on gradients, preventing rollback on uphill stops without requiring any handbrake application or accelerator brake overlap technique. The car simply holds its position until forward motion is commanded. Most Mazda owners have driven past this button on the center console for years without investigating what it does. The button is typically labeled Auto Hold and sits near the electronic parking brake. That is the entire barrier to accessing one of the most practically useful features on the car. The next secret involves a system that monitors something most drivers never think about until it is too late. Number 11. Driver. Attention alert. What the coffee cup actually means. Most Mazda models from approximately 2014 onward include Driver Attention Alert, a system designed to detect early signs of driver fatigue before the driver becomes aware of it themselves. The system works by monitoring steering inputs continuously during driving above a certain speed threshold. A fatigued driver produces subtly different steering patterns compared to an alert driver. Small overcorrections, slightly delayed responses to lane drift, irregular micro-adjustments that do not match the road curvature. The system builds a baseline of the driver's steering behavior in the first few minutes of driving and then monitors for statistically significant deviation from that baseline. When deviation crosses the threshold, the coffee cup symbol appears on the instrument cluster accompanied by an audible chime. The suggestion is to take a break. The common driver response is to dismiss the alert and continue driving. That response misunderstands what the alert is communicating. The system is not detecting when a driver is unable to drive. It is detecting when the driver's steering patterns have become measurably less precise than their own baseline from 20 minutes earlier. That detection occurs before the driver is aware of any impairment. The next secret involves a physical calibration that many owners never know was skipped after their last windscreen replacement. Number 10. The i-Activsense Camera Calibration. Most shops skip the i-Activsense safety suite in current Mazda vehicles relies on a forward-facing camera mounted at the top center of the windscreen. This camera provides input for lane departure warning, lane keep assist, smart city brake support, driver attention alert, and traffic sign recognition on equipped models. When a windscreen is replaced, the camera must be recalibrated to the new glass angle. The calibration process requires a specific target placed at a measured distance in front of the vehicle with the car on a level surface. The procedure is performed through the diagnostic software and takes approximately 20 to 30 minutes. Many independent windscreen replacement services do not perform this calibration, either because they lack the equipment or because the customer is not informed it is required. A Mazda dealership or an independent shop with access to Mazda-specific diagnostic equipment can perform it correctly. Signs that calibration was skipped include lane keep assist that pulls the car toward one side consistently, smart city brake support activating at unexpected distances, or a persistent warning light for any i-Activsense system after the new screen has been fitted. Driving on an uncalibrated camera does not always produce obvious symptoms. The safety systems appear to function. The calibration determines how accurately they function, and an uncalibrated camera creates systematic errors in every system depending on it. The next feature is one most drivers set once and leave in a default that was never designed to be optimal for every situation. Number 9. MRCC following distance. 4 settings. Nobody adjusts. Mazda Radar. Cruise control has 4 selectable following distance settings. On most Mazda models, they are selected by pressing the distance button on the steering wheel, cycling through 4 options indicated by bars on the instrument cluster display. Most drivers select a distance during their first use of the system, find it acceptable, and never touch the setting again regardless of speed, traffic conditions, or weather. The intention behind having 4 settings is to allow the driver to match following distance to conditions. Setting 1, the closest, is appropriate for dense urban traffic where maintaining a large gap simply results in continuous lane changes by other vehicles filling the space. Setting 4, the furthest, is appropriate for motorway driving at high speed in light traffic, providing maximum reaction time for the car's braking system. Settings 2 and 3 cover the range between. Running setting 4 in city traffic means the system holds a gap frequently filled by other drivers, causing unnecessary braking braking cycles. Running setting 1 on a motorway at high speed means the gap to the vehicle ahead is smaller than braking distance requires in a genuine emergency. 5 seconds adjusting this setting to match conditions is the difference between MRCC that feels smooth and appropriate and MRCC that feels awkward and marginally unsafe. Hit the like button right now. Just one tap. Number 8. The blind spot monitoring reset after tire work. Mazda's blind spot monitoring and rear cross traffic alert systems use radar sensors mounted in the rear bumper. These sensors work correctly when the bumper is aligned to factory specification relative to the vehicle center line. After any work that affects the rear of the vehicle, including bumper replacement, bumper removal for access to other components, or rear-end repairs, the sensors may require realignment and recalibration. The same applies in some cases after significant rear suspension work that alters the geometry of the rear of the car. A misaligned BSM sensor typically presents as an alert pattern that does not match the actual position of approaching vehicles. The system may alert to vehicles that are already past the blind spot zone or fail to alert to vehicles that are genuinely within it. Either error undermines the usefulness of the system. The diagnostic reset procedure can be accessed through the Mazda diagnostic software at a dealer or through a compatible third-party diagnostic tool. It is not accessible through the standard driver settings menus. Owners who have had rear bumper work completed at a non-specialist body shop and subsequently noticed that BSM alerts seem poorly timed relative to actual vehicle positions should request a sensor alignment check rather than assuming the system is simply unreliable. The next secret involves something Mazda did with the door mirrors that most owners reverse within the first week of ownership. Number 7. The mirror setting that eliminates the blind spot entirely. Every Mazda comes from the factory with door mirrors set to a position that produces a blind spot roughly 1 car length to the rear quarter of the vehicle. Most drivers accept this as a fundamental feature of driving and perform shoulder checks to compensate. The blind spot is not fundamental. It is a calibration choice, and the correct calibration eliminates it almost entirely. The method is to adjust each door mirror outward from the conventional setting, until the side of your own car is no longer visible in the mirror at all. In conventional mirror setting, roughly 1/3 of each mirror's field of view shows the side of your own car, which is wasted. Adjusted outward to remove that overlap, the mirror's full field of view covers the lane beside and behind you rather than your own door panel. In this position, a vehicle approaching from behind is visible in the rearview mirror. As it moves to your side, it transitions from the rearview mirror to the door mirror. As it moves further forward into the area beside your car, it appears in your peripheral vision through the side window. The transition is continuous. No gap exists. Most drivers who try this adjustment find it disorienting for 2 to 3 days because the car's own bodywork is not visible. After that adaptation period, shoulder checks become confirmation of what the mirrors already showed rather than primary blind spot checks. The next secret involves something that happens at every fuel stop, and most owners are getting it slightly wrong every single time. Number 6. SkyActiv G fuel grade and what actually happens at the pump. SkyActiv G engines run at a compression ratio of 13:1 in most markets, with some versions reaching 14:1. This is extraordinarily high for a naturally aspirated petrol engine. The engineering required to achieve this without engine knock at standard fuel grades involved a specific exhaust gas recirculation design and a carefully shaped combustion chamber. The result is an engine that meets its published performance and economy figures on regular grade fuel, which is the minimum 87 octane rating in the United States. The engine management system is calibrated for this fuel and performs correctly on it. However, SkyActiv G engines also respond measurably to higher octane fuel. The engine management system can advance ignition timing further on 91 octane fuel because knock resistance is higher. The improvement is typically in the range of 2 to 4% in fuel economy and a small increase in response, feel rather than peak power. Mazda does not recommend premium fuel as a requirement. They calibrate to the minimum specification. The performance delta available from running higher octane is real but modest, and whether it justifies the price premium is a calculation each owner makes based on their market's fuel price differential. What premium fuel does not do is protect an engine not designed for it. SkyActiv engines do not require it. The benefit is optimization, not protection. The next secret involves a feature hidden inside the automatic transmission that transforms how the car responds under load. Number 5. Sport mode. Shift points and what they actually change. Mazda automatic transmissions on most current models include a sport mode selectable through the gear selector or a dedicated button. The name suggests performance. The reality is more specific and more more useful than the name implies. In standard drive mode, the transmission prioritizes fuel economy. It upshifts at the earliest opportunity, keeps engine RPM low during steady cruising, and delays downshifts to maintain momentum rather than increasing engine output. This is optimal for relaxed driving, but produces a disconnected feel during more spirited use because the engine is rarely in the range where it produces meaningful torque. Sport mode raises the upshift RPM threshold significantly, meaning the transmission holds gears longer before changing up. It also downshifts more aggressively and at higher engine speeds in response to accelerator input. The engine operates in a higher RPM range where the i-Activsense's torque curve is more consistent and the throttle response is more immediate. The practical result is a car that feels substantially more responsive without any actual change to engine output. The same horsepower is available in both modes. Sport mode simply keeps the engine in the range where that power is accessible rather than allowing the transmission to constantly seek the lowest possible RPM. Combined with the manual paddle shifters on equipped models, Sport mode transforms the driving character of any current Mazda automatic from efficient to genuinely engaging in a way that most owners never experience because they have never moved the gear selector one position to the left. The next technique involves something that happens before you even leave the driveway every morning. Number 4, the cold start. Idle sequence and why interrupting? It matters. i-Activ engines run a specific idle sequence on cold starts. For the first 30 to 60 seconds, the engine manages its own temperature, fuel mixture, and idle speed through a calibrated protocol designed to bring all systems to operating temperature efficiently without thermal shock. During this window, the engine may idle at a slightly elevated speed. Fuel consumption is higher than at operating temperature, and oil pressure is being distributed through galleries and passages that have drained partially during the overnight sight. Driving immediately from cold start is not catastrophic for a modern engine. The systems are designed to handle it, but it is not optimal. The oil pressure takes several seconds to fully distribute. The cylinder walls are not yet at the temperature where the piston rings seat with optimum clearance. The catalytic converter is not yet at operating temperature and is not effectively processing exhaust emissions. Mazda engineers include an idle warm-up recommendation in the owner's manual precisely because the engine performs better and wears less when the protocol is followed. Most owners ignore it because most modern automotive advice says warm-up is unnecessary. For a i-Activ engine with a compression ratio requiring precise piston ring seal, 30 seconds of idle costs nothing and shortens the period of slightly suboptimal lubrication that happens regardless of whether the car is moving or stationary. The next secret involves a feature in the infotainment system that most owners fight rather than learn. Number 3, the Mazda Connect rotary commander. Functions most owners never find. Mazda Connect's commander knob is a rotary dial with push, tilt left, tilt right, tilt forward, and tilt backward inputs in addition to the rotation itself. Most owners use rotation and push exclusively because those are the most obvious inputs. The tilt left function from the home screen is a direct shortcut to the audio source selection, rather than navigating through menus to change from radio to Bluetooth or from a connected phone to a USB source. A single tilt left from any screen jumps directly to the source menu. This shortcut eliminates 2 to 3 navigation steps for the most frequently performed function in the system. Tilting the commander while in a menu scrolls the selection in the direction of the tilt, rather than requiring rotation. This produces faster navigation through long lists than rotation does because the tilt is a discrete input rather than a continuous one. During navigation, pressing the volume knob rather than the commander knob accesses a quick menu for the current navigation guidance, allowing route options to be accessed without returning to the navigation home screen. None of these functions are labeled. None are mentioned in the standard owner orientation at most dealerships. They exist in the owner's manual in a section most buyers never read because the system appears straightforward enough to operate without documentation. The system becomes significantly faster to use once these inputs are understood. The next technique involves something Mazda specifically calibrated that most owners accidentally defeat every time they inflate their tires themselves. Number 2, the chassis geometry. Secret. Hidden in the tire pressure. Setting. Mazda's suspension geometry on every current model is calibrated to a specific tire pressure. That pressure is printed on the door jamb sticker. It is not the maximum pressure printed on the tire sidewall, which is what many drivers use when inflating tires themselves. The door jamb figure represents the pressure at which the suspension geometry delivers the handling and ride characteristics Mazda engineered for the specific model. At this pressure, the tire contact patch is the correct shape for the camber and toe angles of the suspension design. The steering response, cornering balance, and ride compliance are all calibrated to this figure, running higher pressure than the door jamb recommendation. Common among drivers who associate harder tires with better performance changes the tire contact patch to a smaller, more central shape. The tire runs on less rubber, the ride becomes harsher, and the cornering feel changes in ways that are not aligned with how the suspension was calibrated. The steering may feel more nervous without actually being more responsive. Running lower pressure than the door jamb recommendation produces a larger, more irregular contact patch with increased rolling resistance, reduced reduced steering precision, and higher tire wear on the outer edges. The door jamb figure is not a suggestion, it is a component specification in the same way that the correct oil viscosity is a specification rather than an approximation. Inflating to that figure and checking it monthly is the lowest cost performance optimization available to any Mazda owner. Number 1. The complete Jinba Ittai, protocol, and why it changes everything. Every secret on this list is a component of the same design intention. Mazda builds every car around the belief that a driver who is correctly positioned in a correctly calibrated car, using correctly understood features, will have a fundamentally different experience from a driver who simply gets in and drives. The complete Jinba Ittai protocol combines every technique on this list into a single daily habit before driving. Seat adjusted to the Mazda intended position with hip point level, with the knee and forearms at a slight downward angle to the wheel. Door mirrors adjusted outward to eliminate blind spots. Tire pressure confirmed at the door jamb specification. For cold mornings, 30 seconds of idle before pulling away. During driving, MRCC distance adjusted to match conditions. Sport mode engaged on roads where engine response is preferable to economy. Auto hold used at stops to reduce cumulative fatigue. Driver attention alert treated as actionable information rather than a nuisance. Understanding G-vectoring control, plus is operating on every corner means the steering inputs that feel most natural are the ones the system is designed to work with. Smooth, deliberate steering in and out of corners. The system enhances smooth inputs and cannot enhance sharp ones. For an owner who has been driving in default settings with default mirror positions and default seating since purchase, implementing the full protocol produces a car that feels noticeably different from one drive to the next. Not because anything changed mechanically, because the driver finally positioned themselves in the relationship with the car that Mazda engineered from the beginning. 15 secrets, one consistent philosophy behind all of them. A car that has been trying to deliver something specific since the day it was built, waiting for its owner to meet it where it was designed to be met. That is everything most Mazda owners will never be told at the dealership showroom. Click the video showing on your left right now because it covers 7 more Mazda-specific maintenance habits that protect the engine features you now know exist and keep them working the way they were designed to for the life of the car.